Hello, I'm Amos Azaria from Ariel University, and I'm going to talk about the internal state of an LLM knows when it's lying. This is joint work with Tom Mitchell from Carnegie Mellon University. One of the biggest problems we have with language models is that they generate false information. This can happen for several reasons. One of the reasons is that language models generate a token at a time, and each time they generate a token, they actually commit to the token generated. So if, for example, the sentence starts with Pluto is the, so the language model may pick the word smallest, which may make sense in comparison to other words it could choose. But once it picks the word smallest, continuing the sentence in a correct way is quite complicated. So instead of continuing it in the correct way, the LLM may choose to complete it with the words dwarf planet in our solar system. And this is exactly what GPT-4, the way GPT-4 completed the sentence when it was asked. So the problem is that Pluto is not the smallest dwarf planet, it's actually one of the largest dwarf planets in the solar system. The correct way to complete the sentence is that Pluto is the smallest celestial body in the solar system that has ever been classified as a planet. Okay, there are also other reasons that language models may generate false information, but we'll keep going. So the goal of this work is to try and detect and possibly also correct instances when a large language model generates false information. To that end, we created the true-false dataset that has many different topics, and it has many sentences, and each sentence is either classified as a true sentence or as a false sentence. For example, a true statement can be the atomic number of hydrogen is 1, and a false sentence may be the atomic number of hydrogen is 34. Okay, all this data set was generated based on a table that contains information about different chemical elements or different cities, etc., etc. Here are some more examples from the data set. So true examples, maybe boron is used in the production of glass and ceramics, and a false statement, maybe indium is in the lanthanide group. Okay. Now, with all these sentences are fed into a large language model, and then we test the internal state of the language model and for each of these, when each of these sentences is fed. On top of this, we build a classifier. Now, since we know which sentence is true and which sentence is false, so we can actually create a classifier that gets as input the internal state of the language model for each of the sentences, and the label is whether the sentence is true or false. Now, with Saplema, which is actually just a classifier, a small neural network. This Saplema can supplement a large language model, and then every time a language model generates a sentence, it can be fed into Saplema, and Saplema can say if it's true or false. So as for the results, Saplema reached accuracy levels of between 60% to 90%. This depended on the model we used. So we used two models. The first model was OPT 6.7 billion, and the second one was Llama 2, 7 billion. Llama 2 performed much better. And it also depends on the topics. So some topics like cities, the Saplema performed much better, and some topics like chemical elements, it didn't perform as well. Now, the few-shot prompting did not reach anything above 56% accuracy and performed quite poorly. Saplema, we also show that Saplema performs well when tested on statements that were generated by the LLM, by the OPT 6.7 billion parameters model. And since Saplema uses a very small network, it can just supplement the LLM, and every time the LLM generates a sentence, a statement, Saplema can test if it's true or false, and then it can decide if to erase that sentence or to mark it at least, I'll talk about it a little bit later. Okay, we also compare the results of Suplima to just measuring the probability according to the model of each of the sentences, and we show that Suplima performs much better. So, as I said, in future work, we would like to have experiments with people. Some will interact with the original language model, and others will interact with a language model with Suplima that will actually determine if a sentence is true or false, and then we'll either erase untrue sentences and regenerate sentences instead, or just mark them to the users. Thank you.